All right, so the last part we're going to talk about today is graphs of both exponential and logarithmic. For the most part, you guys have dealt with exponential graphs before, and you should have dealt with log graphs before as well. But we're just going to touch on a few key points. So first of all, exponential graphs never cross the x-axis unless they're shifted down. This one is an exponential growth, right? We're going up. That's the main part about our exponential graph. Obviously, if we shift it around or shrink and stretch it, it's different, which we may talk about later in the year, may not. Another part, the main part of why we deal with logs in this section is that the connection between the two. Right. So in the previous video, they talked about how they're inverses of each other, and that's the main reason for even having a log, right? Most people are like, why do we need this? It's just like three made up letters. Yeah, it's three made up letters, but it means something because it can be used for something. So if we look here, our inverse is when we have this line y equals x, and we reflect the graph over it, right? So if we reflect this graph over it, we get something that looks like that. Which if you notice, hey, it looks pretty similar to that one, right? Because the log function is the inverse, right? Which is when you reflect over that y equals x, or all of your x's become y's, all of your y's become x's. And so now instead of having a horizontal asymptote, we have a vertical asymptote, right? So we never have negative x's. Over here, we never had negative y's. Over here, we never have negative x's. Obviously, again, if you shift it, shrink, stretch, transform it some, you may end up shifting it over something like that, but we're not going to talk about that right now. So the main thing is that we have negative x's. Also notice it goes through this point 1, 0, where this one also goes through 0, 1, right? So that's how the inverse, right? We flip it. So those are just a couple key things about the graphs. Notice for exponential, we either, exponential growth, exponential decay, where here our log starts off really a lot and then levels out instead of starting out a little bit and then leveling out, or then exponentially growing.